This is your pre-lab video for Chem111's periodic properties of the elements. You'll be happy to know that this is a pretty short video as we do not have any calculations to do, so that should be helpful for you this week. Determining the reactivity of the trends of the periodic table, that's what we're doing in lab this week. So trends, meaning how do the elements compare as you compare them from top to bottom of the periodic table or as you go left to right and the various just sections within the periodic table. So that's really what we're focusing on this week. So we're doing a series of reactions, either keeping the group the same or the period the same. And then we can compare the observations that we make and make a determination of whether or not the reactivity increases as you go from top to bottom or go from left to right across the periodic table. So this is a qualitative lab, so we're very interested in the observations. That's your data for this week. And I want those observations to be in your notebook, okay? There's not going to be a formal report this week. You will have, and I'll give you copies of the report form that you can fill out and hand in. So no formal typed up report, but you do have to record your observations in the notebook first. Then you can transfer them over into the report form nice and neat to hand in for your lab instructor. And also attach those copies of your notebook pages to that report form before you hand it in. Safety and housekeeping is very important for this lab. We're working with a lot of different chemicals. We're doing a lot of different types of reactions. Make sure you wear appropriate clothing. Make sure you have the appropriate shoes. Do not wear hairspray. Keep your hair tied back. All of those kinds of things. Consider wearing long pants. Please, we are working with quite a few different chemicals. You do need to have at least shorts that are long shorts ordinarily, but consider wearing long pants this week. It's really important this week to pay attention to where your used metals end up. Okay, we cannot throw them in the garbage. This is a fire hazard. We've had fires in the past. Any unreacted metals, even and actually especially in powder form. If you spill it, don't just sweep it up with a paper towel and throw it in the garbage. There is a designated container in the hood for these metals. Very, very important. The reactions of lithium and sodium are to be done in the hood that they're set up in. This will either be a demonstration by your instructor or you will be doing them, but make sure you do them in the hood. So I recommend just taking turns going over and doing these reactions and then letting the next group know when they can go. Acid solutions may go down the drain, but the hexane solutions that we're going to be using for the halogen reactions must be collected in the waste container in the hood, and your instructor will point that out. When you're testing your reactivity in flame, please keep your face back. I've seen some of these reactions be quite violent and have a little mini pop or explosion. Just keep your face back. Don't be hovering over the flame, obviously, and keep your hair tied back. Remember your acid safety and your base safety as well. We are working with some acids this week, and some of your reactions will be producing a basic solution. So just keep in mind your acids and base, that safety. Wash your hands thoroughly. Certainly if you feel any burning sensation or even if they just come in contact with any of the chemicals, wash your hands. We have gloves available if you'd like to wear those as well. When you're done with the lab this week, please make sure that you wash your hands and wash and wipe dry your lab bench. Make sure you wash it before you come in, like as soon as you arrive, and then before you leave. The hoods and the common areas, it's very important this week to keep neat, and any spills, make sure you wipe them up immediately. Let your instructor know if you've made a large spill. So you will follow through with all of the different types of reactions that you see in your lab and follow along with your lab report form. When you get to the reactions of the halogens, I just want to point these out. I'm not going to go through each and every one. You're going to be able to determine the reactivity through your observations, but the halogens are tricky for folks. So I want to just spend a few minutes on what it is we're looking for and how do you interpret what you see. So we're looking at chlorine, bromine, and iodine. And we're comparing the reactivity between these three to determine what the trend is. So you will have solutions of these halogens, okay, so in their elemental form, dissolved in water. And you'll be recording what those look like dissolved in water. You'll also be recording what these look like and what colors they are dissolved in hexane. And you're going to use that in your interpretation of your reactions then. This table here shows you when you're reacting, say, chlorine element, so that's this chlorine element here on the left, with a salt, a bromide salt. So in this case, it's potassium bromide, and that's why the Br is in an ion form here. So the K is on both sides, right? The potassium ion is in both sides, but it's just a spectator ion. This is a net ionic equation for the reaction of chlorine with bromine ion if this reaction takes place. And you're going to determine whether or not this reaction takes place. So if this reacts, this is a single replacement reaction where chlorine, if it's more reactive, will replace the bromine in the salt. So it will become an ion. The bromine then gets replaced and it gets spit out as its elemental bromine. So how do you know if this reaction takes place? Well, you know what the chlorine looks like in hexane, and you know what the bromine looks like in hexane. And when you mix these together, you're going to mix them together in a test tube, and it's really important that you swirl it. And you keep swirling it, and you make sure that it's fully mixed, fully reacted, and that you have dissolved in the hexane the halogen that is in the elemental form. Okay, so these halogens are preferentially dissolved in hexane over water. So you're going to look at the hexane layer, and that's on the top, and look at that and say, okay, is that the color of bromine when it's its element, or is it the color of chlorine when it's in its elemental form? And that will determine whether or not if it looks like chlorine, then it didn't react. If it looks like the color of bromine, then it did react. And if it did react, then that means that chlorine was more reactive than bromine. So that's what we're looking for here. All of these different reactions that are taking place, you will have all of your observations in your report form, and you're also going to have to write the chemical equation for what happened. So you can do that at home, but make sure you take your time writing the equations. You will be graded on the accuracy of those, as well as how complete and accurate your questions are at the end of this report form. So take your time with those and have fun with this. This is a pretty fun lab.